Hello everyone, great to see you again. Now imagine a world where you no longer need your chemical fertilizers, but instead you have millions of bacteria busy converting nitrogen from the atmosphere into the food that plants need. Now imagine what that would mean to you if you're a farmer, or what that would mean to you if you are someone who is concerned about the impact of chemical fertilizers on the environment. So imagine no longer, because currently that's happening in some parts of the world, specifically in America, that's currently happening. And so just a bit about chemical fertilizers, right? So as far back as 1900, one of the pioneering scientists, Fritz Haber, the German scientist, was able to find a way for us humans to capture the nitrogen that is in abundance in the atmosphere. Remember, the air you see, or the atmosphere, is about 78, some would say approximately 80% of nitrogen. So this scientist, genius, who actually won a Nobel Prize for that, was able to find a way of, at high temperature, capture that nitrogen from the atmosphere and combine it with hydrogen from natural gas, and that would then help us to form ammonia, NH3, for elementary chemistry. Now that ammonia can then be converted into ammonium nitrate, which is the food or the fertilizer that we apply to crops. And so since that invention, I mean, just to think about that a bit, then the population of humans on this planet was about 1.6 billion. Today we are looking at 8 billion, or more than 8 billion people on the planet Earth. So imagine, if you can for a bit, how it would have been possible to sustain that kind or that level of population explosion without this kind of inventions. There's no way we would have been able to feed humans. But that great technology is not without its disadvantages. Chemical fertilizers, number one, the process of making them contributes a huge amount of greenhouse gas to the environment. I mean, current calculations places it around 1.5% of the global greenhouse gas emission is from the manufacture, transportation, and use of chemical fertilizers. So that's just one of the many problems. Fertilizer application has its own downsides, because oftentimes a good portion of that fertilizer that we apply get washed into receiving waters. And what that means is those chemicals end up harming the microorganisms, the fish, and all the other things we have in the water. In some developed countries, like in the UK, we have the farming rules for water. And if you look into the details of those rules, you would see that actually, if those rules are followed, some of these things can be taken care of. For instance, farmers are kind of required to be able to know the amount of the chemical fertilizer that would be taken up directly by the plants, so you don't apply more than what is needed. Farmers are required to kind of study the environment to be sure of the amount of rainfall we're going to have, so that you don't have much of it washing into receiving waters. But with the impact of climate change, it's becoming practically impossible to be able to monitor or to predict how much rain. Imagine just recently in France, we had a whole year's worth of rain dropping in about 8 hours. So how on earth are you meant to predict such? So inevitably, most of these chemicals that are applied as fertilizer gets washed off into water and causes loads of problems. Now, that's the second concern. The third thing is ammonium nitrate is a very, very good explosive. In fact, some people have said that Fritz Haber can be credited for feeding the planet as much as being credited for causing or being responsible for some of the war that we've had. So, because from the First World War until now, ammonium nitrate has played a significant role in munitions and some form of chemical warfare. So it's not like chemical fertilizers are like a golden bullet solving all the problems. There are loads of problems with chemical fertilizers. So when scientists like Chris Voigt of the MIT, Massachusetts Institute of Technology, was able to basically take the DNA of a bacteria and reprogram or re-engineer it to function like a basic calculator. I mean, it's like the windows of heaven opened for scientists to be able to start thinking of how to take these bacteria and make them to do the things that they wouldn't ordinarily do. So this process of bacteria taking nitrogen from the atmosphere and converting it to plant food is something that already exists in nature. Again, back to elementary agriculture. So you would have heard of leguminous plants or legumes. I hope I'm pronouncing it right. So those plants like your beans or peas, plants like your peanuts, peas, those are legumes, and they have the ability. So the roots have the nodules that have the bacteria in them, that have this symbiotic or this win-win relationship between the roots and the bacteria. So the roots provide the sugar that the bacteria take and use as food, and in return they are able to capture the nitrogen in the atmosphere and convert it to a form that the plants can use. Now, that process already exists in nature. It's not usually the most efficient, and not all plants are able to do that, have that relationship with the bacteria. And something else that happens is once we apply chemical fertilizer, that process kind of stops. The bacteria just go no longer interested. And so what scientists, building on the work of people like Chris Voigt, have been able to do is to take some of these bacteria, re-engineer them so that even when we apply chemical fertilizers, they do not stop doing what they should be doing. Also helping them to be able to do it more efficiently so that more of the nitrogen can be converted to forms that plants can take up. And so with that technology, currently in several parts of the Corn Belt in America, and I think one of the biggest companies behind it is Pivot Bio, they have successfully trialed this thing, and it has worked in mysterious ways. In fact, according to one of their reports, in 1 year, they have been able to reduce the greenhouse gas emission to a quantity that can be equated to burning 1.5 million barrels of oil. So that, in my opinion, is a significant development, and they are encouraging use of this engineered bacteria. But it's not all rosy, because some people have actually expressed strong concern, and those concerns range from things like, now, so you've engineered these bacteria, you're releasing them into the environment. Yes, they would do what you want them to do, but once that is done, what happens to them? Do they start doing what they shouldn't be doing? Remember, the line between good bacteria and bad bacteria is very thin. So we've got some bacteria, we've got bacteria in our gut and in our mouth that do a lot of useful things for us. But there are some bacteria that once they get into your system, make you sick. So the fear some people have expressed is, what's the line between these engineered bacteria doing what we want them to do and going rogue and doing things we don't want them to do? Now, the scientists behind this technology have said that the bacteria actually die out once the work is done. But counter argument is that yes, they've said that, but no much evidence have been provided to show that they actually die out completely. Because if you have 99% of them dying and 1% of them left in that space, who knows what can come out of that? So those are arguments. Some have taken the argument a bit far, some that we could describe as conspiracy theories, who have said we could have some genetically modified bacterial Armageddon where the earth just comes to an end, apocalyptic occurrence where the bacteria just go rogue and just decide to take over the planet or something like that. That, in my opinion, might be a bit extreme, but the fact of the matter remains that whenever scientists or humans try to intervene in natural processes, chances are that that can result in some things that we do not desire. So the debate is still raging, and one of the things I would like to invite you to do is to tell me what you think. Do you think it's a good move in the right direction? If you are a farmer, would you adopt this technology? But the strongest argument in all of this conversation for me is, it is not as if we have a 100% rosy situation and we're trying to upset the system. We have a situation where we are under threat from climate change. So if this technology is able to reduce the greenhouse gas emission from agriculture, isn't it worth exploring? Because it basically comes down to a choice. Do you wait to see how far climate change takes us, or do we intervene with some of these technologies that might be a bit uncomfortable? That basically is the crux of the argument. So let me know what you think in the comment section. And if you found this video interesting, please like, share, and subscribe for more eco tips. Cheers.